Hello everyone, in this recording we'll discuss how to do interactive visualization of geospatial data. First, let's look at the Leaflet package. So this is an R package for making interactive maps. This is an example. So it's showing the just circles at different cities, and the size of the circle is the population of those cities. You can zoom out, you can zoom in, you can pan, move across. So how do you make this kind of map? It's actually only a few lines. Cities is a data frame which contains the latitude, longitude, and population for each of these cities. Notice it's just a data frame. It's not a spatial data frame. So to use Leaflet, you don't even need spatial data. So I pass in that data frame into the Leaflet command. That allows me to refer to these columns later on. This first layer, add tiles. Tiles refers to this kind of background map. Right? So like the thing that's drawing all the state boundaries, that's drawing the water bodies and the forest, that is the tile. There are actually a few different kinds of tiles. So maybe you want just a pure physical map without the state boundaries. Maybe you just care about the state boundaries, but not the physical map. You can just set different tiles and they would show different backgrounds. Add circles, that's what's drawing the circles, and it's encoding these data frame properties in the location and the size of the circles. So that's all. There are actually a few other kinds of markers you might want to add, but this is the most basic kind of Leaflet map. Something that's kind of cool is you can embed Leaflet into Shiny. So let's look at an example from the Shiny webpage called the Super Zip Explorer. This is what it looks like. You also have this little pane that shows it's like percentiles of population and then income and education levels, right? When I zoom in, so if I, let's say, like zoom in Minnesota, Wisconsin area, right? Okay, we can zoom into Madison and it's showing college and income, so education levels and income within all the zip codes in the current view. Right. So how do you build this kind of map? Let's look through the main code. Okay, the first thing that happens in the server is I have a render leaflet, and it's just drawing the background tiles. It doesn't even refer to any data set. It just adds default background tiles and it centers it at the center of the US. I don't even show any circles at this point. Now the next thing let's think about, after you've initialized this map, is about how does it even know what are the current zip codes within the view? The trick is, whenever I initialize a leaflet map, it automatically creates a certain kind of input. And so we're familiar with select inputs, drop-downs, slider inputs. Right? These are very explicit kind of inputs, but there's actually an implicit input whenever we use Leaflet. The implicit input is the bounding box of the current view. And that's stored in this input $map bounds variable that's available whenever you're in the server. So this zips in bounds is taking the overall data set and then filtering it to just the bounding box. So all of this calculation is just trying to get the bounding box of the current view, and then it's filtering the data according to the latitude needs to be above the minimum latitude, but below the maximum latitude, and same with the longitude. Okay. So this creates a reactive that's going to rerun every time I pan or zoom the map, and it's going to recalculate a subset of the zip code data that's just for the current view. Now this is a reactive, and there are two outputs that depend on it. There's an output on the histogram, and there's an output for the scatter plot. Both of these are going to be recomputed every time the map view changes. And so this is how you're able to update the histogram and the scatter plot every time the map view is changing. Now, the last part I wanted to mention, how is it actually adding the circles? So this block, this is all contained within an observer. What it's doing, Leaflet Proxy, this is a way of modifying a leaflet map in place. If you called leaflet every time there was some sort of interaction, it would really slow down the interaction because it would have to redraw the leaflet map every single time. That would get extremely tedious. Leaflet Proxy is able to update an existing map in place, so it becomes very efficient. So it's referring to the existing leaflet map, which in this app is called map. It clears any shapes that might have been there before, and then it's redrawing a bunch of circles. It has to redraw it because there's an option in this app to change the colors. In general, if we didn't need to change the colors, we wouldn't need to redraw it every single time. But okay, this is the point where it actually draws the circles and also adds a legend. So this is all interactive visualization with Leaflet. Let's do some D3 again. Here I have created a map where each of these little paths is a little county. Right? I've created it using D3 Geopath, just like we talked about in the last lecture. And I can mouse over, here I'm pressing the shift key and mouse overing, and it's highlighting some properties. This is totally random data, so these are supposed to be the average of the value for all that county for one attribute, and then here's for the second attribute, so maybe it's like income and education level. It could be average across all the selected regions. But the point is just, these are little SVG paths. I can add a mouse over kind of command, and then as I'm clicking on them, it's adding the ID of the county to a long list. And then I'm using that change to also redraw for the current values in that list, what is the average value? Right, so the average income, the average unemployment within that current list. So that's how you can define a query based on these paths to update some other plot. This is the actual code I used to do it. You can, if you follow this link, you can see the entire code. All it's doing is it's changing the fill. It's changing the fill according to whether I'm in the current list. And then it also updates the height of these bars. And it's smoothly transitioning, which is why it was kind of nicely growing up and down. Okay. It's almost the same as in the glaciers example. It was using a mouse over to change the name in some tooltip. So that's one way. You could also imagine using some other plot, external plot, to highlight features on a map. So here's that urbanization in East Asia example. Here, when you hover over a bar, it's highlighting all the urban areas within that country. So it's just a kind of linked view. And then when you hover over a specific urban area, it gives some details of that urban area in the box. Okay, so here's another kind of example where I can either hover directly on the map, or I can make selections based on a bunch of time series. Right, so here are all the time series within this kind of 2D, or this envelope, right? And yeah, you can make queries going in both directions. Okay, so that's linked views. A final kind of idea that's often useful with geospatial data, it's not exactly interaction, but it can be kind of nice, is use animation. So this in the example, it's showing soccer data. So these are where people are running when they're trying to score a goal. You can see maybe there's some people who are starting out here, but these are kind of the most common paths, right? And it's just animating all the paths across this entire data set. So kind of the amazing thing, this is all done in D3. And I'm not going to go over the detail about how this one is made, because this is a bit more sophisticated. But if you're curious, all the code is visible at this link.